Hello, 8th graders, and welcome back to the Math Virtual Learning Session of Future Educators Talk. So let's get this started here with another lesson from me. So the last time that we was on, we covered equations. I finished up that last YouTube video of equation with a denominator, and then I'll show you guys some notes of how to solve an equation and also how to create an equation from word problems. Then also introduce you guys equations with parentheses. So I covered that on the last lesson. And today is review day. We're going to be reviewing what we have been learning, equations with variables on both sides. So that's what we're going to be reviewing today. And then also right after, I'm jumping right into a new lesson, which will be numbers of solutions. So let's get this started here with the review. So make sure you guys have out your notes. And your notebook, your pencils to copy this review down. Now, I don't know if I'm going to leave myself up here or should I hide myself, but let me put this to full screen and we will get started. um, let's see. I probably am going to hide myself, so I'm going to hide myself now. That'd be best. Okay. Now, multi-step equations review. So we are reviewing equations. So let's see what we have first. Okay. Now, when solving an equation, our goal is to find the value of the variable that makes the equation true. Did you hear what I just said? Let me reread it for the ones in the back. When solving an equation, our goal is to find the value of the variable, that whatever it is that we have that makes our equation true. Because if our equation is not true, then we have did something incorrect. If our numbers don't match up with each other when we check back our work, then we have did something wrong. Ladies and gentlemen, we have did something wrong. Okay, so let's see what we have first. Step one. Our first example is a two-step equation. So let's look. So we're going to solve for x. And here's our lovely equation. And let me scoot this down. Make sure you guys copy this down here. And I'm scooting down. So a two-step equation. So let's solve for x. We got 3x plus 7 equals 13. Now, we need to get x by itself. Before we do anything, we need to get x by itself in every equation, ladies and gentlemen. In every equation that we do, we always need to get x by itself. And that's why I have down here. We need to manipulate the equation to get x by itself. So let me highlight that for you guys. Actually, I'm going to circle it. And you guys know I always use blue because that's my favorite color. We need to manipulate the equation to get x by itself. That is our main goal, is to get x by itself. So what do we need to do here? Before I scroll down, what do we need to do? And again, I'm still feeling like you guys are like right in front of me, but you're not. So what do we need to do? We got 3x plus 7 equals 13. Well, to get x by itself, we need to subtract 7 from both sides of the equation. So we're going to subtract 7 here. Subtract. Well, I have it down here. We're going to subtract 7 on both sides. Okay? And also right here as well. It won't let me write right there, but I have it down here. Voila. So subtract 7 on both sides to get x by itself. So you're going to bring that down. It's going to be 3x equals, because 7 minus 7 is 0. So that crosses out. So the only thing you have left is 3x equals, well, what's 13 minus 7? Well, 13 minus 7 is 6. And I'm showing you guys too much work. So we got 3x equals 6. Now, to get x by itself, we need to divide by 3 on both sides, on both sides, on both. Let me write that. Divide by 3 on both sides. Sorry, you guys, my handwriting is terrible this morning. You have to do it on both sides. Wherever you do to one side, you need to do it to the other. So you got 3x divided by 3. Well, that automatically crosses out, doesn't it? That crosses out for us. So we're only left with x. X equals, well, what's 6 divided by 3? And here I go again, you guys. Whoa. Oh my gosh. Don't you go? Okay. Let's get back to it. Don't you guys just love technology? Okay. So x equals 2. There's our answer, ladies and gentlemen. Now, let me take this off here to where you guys can see this. Now, we call this a two-step equation, because it took 2 steps to solve. Am I right? Am I right? Yes. If we go back, this is here's 1 step, and here's your 2. It took us 2 steps to solve this equation. Now, the first step was to subtract 7 from both sides, and the second step was to divide both sides by 3, as I have up here. So, 2 steps, you guys. That's why it's called a two-step equation, because there's only 2 steps to this equation. Okay? So copy this down, copy this down. Letting you guys take a screenshot of this. Do whatever you need to do. Okay, so let's move on. Let's go to what we have next. Now, actually, as you can see up here, we are referring back to this equation here, the 3x plus 7 equals 13, because we're going to have to check our work to see that we did it correctly. If not, then we have did something wrong. So let's check and make sure. Now, we check the solutions by plugging 2, because that was our answer. That was our answer, wasn't it? Yes. So we have to plug 2 back into the original equation, which was 3x plus 7 equals 13. And I have it right here. Oops. Now, wherever you see x at, you're going to plug whatever number that you get back into that problem, into x. So for example here, 3x plus 7 equals 13. Well, wherever x is, you're going to plug whatever number that you get into the x. So you have, we're going to do 3 open parentheses, 2 closure parentheses, because we're multiplying, plus 7 equals 13. And I have it right here. 3 times 2 plus 7 equals 13. Okay? And then you're going to solve from here to see, do we get 13? So if we go back to the order of operations, what comes first? You have parentheses, correct? So parentheses, we're going to start with that first. So 3 times 2 is what? 6. So you're going to bring down your 6. So 6 plus 7 equals 13. Okay? Now what's 6 plus 7? 6 plus 7, my friend, is 13. So 13 equals 13. Does 13 equals 13, you guys? Yes, it does, as I have it right here. So you have did it correctly. You have did it correctly. Okay? So good job for you. Good job for you. Now, let's see what else do we have. I'm gonna have you give you guys time to copy this down, take a screenshot. Okay, and we're moving on to, I believe this is it here. Yes, okay. All right, let's go into example 2. What does example 2 give us? What else do we cover from this lesson? Well, we cover, if it will go, variables on both sides, of course. So let's look at example problem. So we're going to solve for A. So we got 5 plus 14a equals 9a minus 5. 2 equations here, you guys. We got 2 sets of equations. So, like I mentioned on our last lesson, on our last lesson, that there are 14, because I'm looking at the 14 here. There are 4 ways that you can solve this problem here. There are 4 ways that you can solve this problem. Either way that you do it, you will still get the exact same answer. So for instance, well, I'm going to do all of it. If we do, you could do where you see the 5, you could subtract 5 on both sides. So you're going to do 5. Let me show you. You're going to subtract 5 here, and then you're going to subtract 5 right here. Okay. If you want to do take away the 14a, minus 14a here, minus 14a here. Subtract 9 on both sides, subtract 9 here, subtract 9 here. Add 5 on both sides, add 5 here, add 5 here. Whichever way that you do, you have to do it on what? Both sides. Because whatever you do to one side, you need to do it also on the other side, because if not, you're going to mess up your problem and you're going to get the incorrect answer. Trust me, you will. So whatever you do to one side, please do it to the other side. Remember that, remember that, remember that. I know I'm speaking quickly, but you need to know it, okay? So let's see what I chose to do here. Now, you could do either way that you want to. Either way that you do it, you should get the exact same answer that I am doing, okay? So if you want to do it my way, you can. But if you want to do the other ways that I mentioned, do that as well. And let's see, do we get the same answer? So let's see, what did I did? Okay, well, of course, we need to manipulate the equation to get a by itself, of course. And let me bring this down. So what I did, I subtracted 9 from both sides. I am getting rid of the non-A, excuse me. So you see, like I explained earlier, whatever I do to one side, I have to do it to the other side. So what you're going to do here is you're going to bring down your 5. So it's going to be 5 plus whatever 14 minus 9 is, bring that down, equals 9A minus 9A. That crosses out. And then you're going to bring down your minus 5. So it's going to be 5 plus whatever equals negative 5. And let's see, what do we get? So it's going to be 5 plus 5A equals negative 5. Okay. Now from here, this is a one-step equation. We should already know what to do. So what do I need to do here? I got to get A by itself. So I am going to subtract 5 from both sides. I'm going to subtract 5 here and subtract 5 here. And I did. This crosses out. So I'm left with 5A equals, well, what's negative 5 minus 5? Negative 5 minus 5 is negative 10. So you got 5A equals negative 10. Now, to get A by itself, I need to divide by 5 on both sides. So 5A divided by 5 gets me just A, so that crosses out. So A equals negative 10 divided by 5 gets me what, ladies and gentlemen? It gets me negative 2. So that is your answer. A equals negative 2. But wait, there's more. I got to check my work to see, did I did it correctly? And if not, did I did something wrong? So let's check our work. Check your work. So 5 plus 14A equals 9A minus 5. Now, wherever I see an A at, I'm going to plug in. I'm going to plug in the negative 2 at. So it's going to be like this. 5 plus 14 times negative 2 equals 9 times negative 2 minus 5. And I have it like this here. 5 plus 14 times negative 2 equals 9 times negative 2 minus 5. Now, again, if we go back to orders of operations, first we have its parentheses. So I need to deal with the parentheses first. 14 times negative 2, and then also 9 times negative 2. So let's see, what do we get? You're going to bring down your 5, so 5 plus 14 times negative 2 gets me negative 28, not a positive 28, it's a negative 28, equals 9 times negative 18 equals negative 18 minus 5. Okay. So let's finish off to see. And what's 5 plus negative 28? Well, you can see the lovely answer here is negative 23. Then what's negative 18 minus 5? Negative 23. Does negative 23 equals to negative 23? Oh, yes, it does. So you did your problem correctly. Excellent. Excellent job, ladies and gentlemen. Okay. Now, I'm going to stop the share now because we are not finished. We are not finished. We still got more review to do. So copy this down here because I'm going to stop the share in 5, 4, 3, 2, 1. So let me show you guys the other review that I have here that didn't make it when I was copying these review down. So Let me show you guys the other review that I have, and I'm trying to find it. Hold on. Hold on. Okay, okay, let me go back. All right, now let me share my screen for the other review. It was right in my face. All right, so here we go here. And I'm gonna do it like this time. And so we have, and well, of course I can't see. So we are, let's see, we are down to example problem 3, which is the distributive property. Now, in case I'm going to just hide myself. Okay, so we are at the distributive property, which we covered on the last lesson. And then also, you guys, I told you that I was going to give you guys some notes the next time that we was on for the distributive property, and I never did. Well, actually, it was supposed to be today because I told you guys in my last lesson. I do have it. I do have it. Um, I have it with me. Hold on for just 1 second. Let me get it. Now, this right here, this notes that I have here, well, of course, I took this back in 8th grade. And it's just notes of what I have. It's just got example problems. It's just got 1, 2, 3, 4. It's got about 5 sample problems on here. So right after this, I'm going to show you guys the notes. I'm just going to hold it up to the screen to where you guys can take a picture of it quickly. Take a screenshot of it. I totally forgot about making this out for you guys, but I do have it. I have it. But anyways, example 3, the distributive property. So we're going to solve for E. And our example problem tells us, well, it shows 7 times 2E minus 1 minus, I said minus 1, yes. 2 times negative E minus 1 minus 11 equals 6 plus 6E. Now, as you can see down here, we need to manipulate the equation to get E by itself. So first, what we need to do is you need to distribute wherever you see the parentheses. So we need to distribute 7 times 2E and then also 7 times negative 1. So 7 times 2E gets me 14E, as you can see down here. Then 7 times negative 1 gets me negative 7. So I got that down. And then you're going to bring down your rest of your equation. Okay. Now we're close. We're almost at a 2-step equation here. Well, technically we already are. But what we need to do here is we need to combine like terms because we got some like terms in these problems here, in this problem here. So we got 14E minus 7 minus 11 equals 6 plus 6E. Well, what is our like terms here? Negative 7, negative 11. And hold on, you guys, I could probably write on here. Yeah, okay. Okay. So here's our like terms. Bam and bam. These, whoops, are combined like Oh, that's terrible. That's just terrible. Hold on, you guys. I could do better. Okay, whatever. So we're going to combine like terms. So what's negative 7 minus 11? Well, it gets me negative 18. So you're going to bring down your 14a minus 18 equals 6 plus 6a. Now we're at a two-step equation here. So there are four ways that you can do it, but in this problem here, they subtract the 6a from, wait, yes, from here and here. So you're going to subtract 6a, subtract 6a on both sides. So yeah. Now, what's 14e minus 6e? Down here it gives me 8e. So you're going to bring down your 8e, you're going to bring down your negative 18 equals 6, because 6e minus 6e is 0. So those cross out. And let me come back to here. Okay. Now, we're down to our one-step equation. We need to get e by itself. So you're going to add 18 on both sides. So you're going to bring down your 8e equals, because negative 18 plus 18 gets me 0. So 8e equals 6 plus 18 gets me 24. So 8e equals 24. We need to get e by itself. So divide by 8 on both sides. 8e divided by 8 gets me just 1. So you're left with e equals 24 divided by 8 gets me, and I probably got to clear everything up. Yes, I did. Okay. Hope you got this down with nines. I'm clearing. And gets me 3. So E equals 3. But wait, there's more. You need to check your work. Wherever you see E at, you're going to plug in that 3 in. So you have it down lovely down here. So you're going to do 7 times 2 times 3 minus 1 minus 11 equals 6 plus 6 times 3. And it has it down right here. Now, we need to do what? Distribute here. Need to distribute here. So 2 times 6 gives me 6. So it's going to be 7 times 6 minus 1 minus 11 equals 6 plus 18. And what we need to do is order of operations. We got parentheses. So you're going to do 6 minus 1, which gives me 5. So it's going to be 7 times 5 minus 11 equals 6 plus 18 gets me 24. So we're still dealing with parentheses, got to multiply, order of operation. 7 times 5 gets me 35, minus 11 equals 24. And we need to see, does 35 minus 11 gets us 24? It does. So you did it correctly. Congratulations, ladies and gentlemen. Okay. And excuse the noise in the background. That is not my background, but excuse the noise in the background. I don't know if you guys are hearing it or not, but excuse that noise in the background. Okay, so let me clear everything because we are finished with These are just example problems. So we are finished. And now, you guys, I'm going to show you, I'm gonna let you guys have time to copy this down here before I show you guys the distributed property notes to this. So I'm gonna give you guys time to copy all this down, excuse me. And that's me. I got some music in the background. Okay. Now I'm going to stop the share right now. Okay, so I hope you guys copy all those down. Now I'm going to show you guys the distributed property notes that I have here. And I want you guys to take a screenshot of this. Don't copy this down. Just take a screenshot of this because I need to move on. So take a screenshot of this here. Hold on, you guys. My earbuds just got tangled with my other. Okay, so let me see how this is going to work. Okay, yeah, this is the glare of the sun. Hold on. Just give me time. Because I don't know if you guys can see this. Let me do it sideways. And hopefully you guys can see this. Okay. Take a screenshot quickly. Okay, go into the back. I'm gonna do it this way. Okay. All right, now let's move on. We're finished with equations. Well, with that lesson of equation for now. We're still gonna be dealing with equations, but now we're going to move on into numbers of solutions. And I have some YouTube videos to show you guys, so pay attention and also take notes. Okay. So the first is numbers of solutions to equations. Excuse me, we're still dealing with equations, you guys. We're still dealing with equations. So number of solutions to equations. So I'm going to show you guys all of the videos today. There are 4 videos, and I'm probably just going to only show you guys 3 of them today, or probably just 2. It just depends. But the first is numbers of solutions to equations. Of course, the intro of it. So I'm going to show you guys this and pay close attention to it. Okay. So let me share my screen. Okay. Now, actually, I want to do something different. Hold on. Because when I be playing these videos, they be buffering. I mean, not well, quite some, and then it just goes slow. But oops. But let me try it this way. Wait a second. Let me stop share and hold on, because I got something in mind. Okay. I don't know if that worked or not. You guys can see my face. Okay. Well, I don't know. All right, here we go.
Determine.
And this is just 5 minutes long. Just wait a minute, you guys. Uh, okay, here we go. And pay close attention.
Determine the number of solutions for each of these equations. And they give us 3 equations right over here. And before I deal with these equations in particular, let's just remind ourselves about when we might have one or infinite or no solutions. You're going to have one solution if you can, by
Copy this
solving the
down.
equation, come up with something like x is equal to some number. Let's say x is equal to, if I want to say in the abstract, x is equal to a, or if we actually were to solve it, we get something like x equals 5 or 10 or negative pi, whatever it might be. But if you could actually solve for a specific x, then you have one solution. So this is one solution, just like that. Now, if you go and you try to manipulate these equations in completely legitimate ways, but you end up with something crazy like 3 equals 5, then you have no solutions. No solutions. And if you just think about it reasonably, all of these equations are about finding an x that satisfies this. And if you were to just keep simplifying it and you were to get something like 3 equals 5, and you were to ask yourself the question, is there any x that can somehow magically make 3 equal 5? No, no x
No,
can
no.
magically make 3 equal 5. So there's no way that you can make this thing be actually true, no matter which x you pick. So if you get something very strange like this means there's no solution. On the other hand, if you get something like 5 equals 5, and I'm just overusing the number 5. It didn't have to be the number 5. It could be 7 or 10 or 113, whatever. And actually, let me just not use 5 just to make sure that you don't think it's only for 5. If I just get something that something is equal to itself, which is just going to be true, no matter what x you pick, any x you pick, this would be true for, well, then you have an infinite solutions. So with that as a little bit of a primer, let's try to tackle these 3 equations. So over here, let's see, maybe we could subtract, if we want to get rid of this 2 here on the left-hand side, we could subtract.
And I do, you guys, I do have some notes for this. I just have to find them. So that's why we're, you guys are watching some YouTube videos of this new lesson here. I do have some notes. I just had to find them.
2 from both sides. If we subtract 2 from both sides, we are going to be left with, on the left-hand side, we're going to be left with negative 7x. And on the right-hand side, you're going to be left with 2x. This is going to cancel, minus 9x.
Correct. You guys should know how to do this by now. Okay. There are many ways that you can do this equation here and still get the exact same answer. Either way that you do it, you're going to get the exact same answer, okay? So in this, there are 1, 2, 3, 4, 5. There are 5 ways that you can break down this equation and still get the exact same answer, okay? Just want to let you guys know that.
2x minus 9x, if we simplify that, that's negative 7x. So you get negative 7x is equal to negative 7x. And you probably see where this is going.
Where did he get the negative 7x? I'm talking about right here. Where did he get that? Well, he combined like terms. 2x minus 9x gets me negative 7x, okay? That's where he got it from. For the ones who are, wait, where did he get that from? He combined his like terms.
This is already true for any x that you pick. Negative 7 times that x is going to be equal to negative 7 times that x. So we already are going into this scenario, but you're like, hey, Sal, I don't see 13 equals 13. Well, what if you did something like you divide both sides by negative 7? Negative 7. At this point, what I'm doing is kind of unnecessary. You already understand that negative 7 times some number is always going to be negative 7 times that number. But if we were to do this, we would get x is equal to x, and then we could subtract x from both sides, and then you would get 0 equals 0, which is true for any x that you pick. 0 is always going to be equal to 0. So any of these statements are going to be true for any x you pick. So for this equation right over here, we have an infinite number of solutions. Let's think about this one right over here in the middle. So once again, Well, let's try to, I'll do a little bit different. I'll add this 2x and this negative 9x right over there. So we will get negative 7x plus 3 is equal to negative 7x. So 2x plus 9x is negative 7x plus 2 plus 2. Well, let's add, actually we do that in that green color. Let's do that in that green color. Plus 2, that's this 2. Now let's add 7x to both sides. Well, if you add 7x to the left-hand side, you're just going to be left with a 3 there. And if you add 7x to the right-hand side, this is going to go away, and you're just going to be left with a 2 there. So all I did is I added 7x. I added 7x to both sides of that equation. And now we got something nonsensical. I don't care what x you pick, how magical that x might be, there's no way that that x is going to make 3 equal to 2. So in this scenario right over here, we have no solutions. There's no x in the universe that can satisfy this equation. Now let's try this third scenario. So once again, maybe we'll subtract 3 from both sides just to get rid of this constant term. So we're going to get negative 7x on the left-hand side. And on the right-hand side, we're going to have 2x minus 1. 2x minus 1. And now we can subtract 2x from both sides. To subtract 2x from both sides, you're going to get, so subtracting 2x, you're going to get negative 9x is equal to negative 1. Now you can divide both sides by negative 9. And you are left with x is equal to 1/9. So we're in this scenario right over here. We very explicitly were able to find an x equals 1/9, that satisfies this equation. So this right over here has exactly one solution.
Okay. So I hope you guys was listening, taking notes, okay? I don't know if I want to show you guys here. Well, let's look at some examples of this. It's just a minute, okay.
Solve for x. We have 8 times the quantity 3x plus 10 is equal to 28x minus 14 minus 4x. So like every equation we've done so far, we just want to...
Okay, so what are you going to do here? Well, first, we need to, if you go back to our last lesson, distribute property. So you need to distribute 8 into 3x and 8 into 10, which is going to get me 8 times 3x is 24x. So 24x plus 80 equals 28x minus 14 minus 4x. Am I right? Let's see.
Isolate all of the x's on one side of this equation. But before we do that, we can actually simplify each of these sides. The left-hand side, we can multiply the quantity 3x plus 10 times 8. So we're essentially just distributing the 8. Distributive property right here. So this is the same thing as 8 times 3x, which is 24x, plus 8 times 10, which is 80, is equal to, and over here we have 28x minus 14 minus 4x. So we can combine the 28x and the minus 4.
You guys didn't call. You guys didn't call of my mistake, because I just brought everything down. Well, of course you can do that, and then you will have to combine like terms, but I just brought everything down. So I hope you guys catch my mistake there. You got to combine like terms. So 28x minus 4x gets me what?
4x. If you have 28x minus 4x, that is 24x. And then you have the minus 14 right over here.
Now, we're at a two-step equation. 4 ways that you can do it. Either way, you're still going to get the exact same answer. So let's see what way he is doing his.
Now the next thing we can do, and it's already looking a little bit suspicious, but just to confirm that it's as suspicious as it looks, let's try to subtract 24x from both sides of this equation.
Okay.
And if we do that, we see that we actually remove the x's from both sides of the equation because we have a 24x there and we have a 24x there. You might say, hey, let's put all the x's on the left-hand side, so let's get rid of this 24x. So you subtract 24x right over there, but you have to do it to the left-hand side as well.
Exactly.
And then we're left with, on the left-hand side, these guys cancel out. You're left with just 80 is equal to is equal to, these guys cancel out as well, is equal to negative 14. Now this
Now,
looks
does 80 equals negative 14? Let's find out.
very bizarre. It's making a statement that 80 is equal to negative 14, which we know is not true. This does not happen. 80 is never
No.
equal to negative 14. They are just inherently unequal. So this equation right here actually has no solution.
So that is your answer for this problem. It's a no solution. Because they don't equal to each other. 80 does not equals to negative 14. Like I said, it never will. Never will. So your answer is no solution, ladies and gentlemen. You could write that down. No solution. All right, let's look at our next video, which is creating an equation with no solutions. Okay.
Whereas to use the drop-downs to form a linear equation with no solutions.
No solutions.
So a no solution linear or equation with no solutions is going to be one where I don't care how you manipulate it, the thing on the left can never be equal to the thing on the right. And so let's see what options they give us. So one, they want us to, we can pick the coefficient on the x term, and then we can pick the constant. So if we made this negative 11x, so now we have a negative 11x on both sides. Here on the left-hand side, we have negative 11x plus 4. If we do something other than 4 here, so if we did, like, say, negative 11x minus 11, then here we're not going to have any solutions. And you're saying, hey, Sal, how did you come up with that? Well, think about it right over here. We have a negative 11x here. We have a negative 11x there. If you wanted to solve it algebraically, you could add 11x to both sides, and both of these terms would cancel out with each other. And all you would be left with is a 4 is equal to a negative 11, which is not possible for any x that you pick. Another way that you think about it is, here we have negative 11 times some number, and we're adding 4 to it. And here we're taking negative 11 times that same number, and we're subtracting 11 from it. So if you take a negative 11 times some number, and on one side you add 4, and on the other side you subtract 11, there's no way, it doesn't matter what x you pick, there's no x for which that is going to be true. But let's check our answer right over here.
Okay. Whoops. Let me go back.
Answer right over here. Whereas to use the drop downs to form a linear, let's check our answer.
Okay. So did you understand what he was saying with a no solutions? If you go back to your problems, some example problems that you copied down from this video, then you will no solutions. Because you couldn't do 11x plus 4 equals 11x. Excuse me, negative 11x plus 4 equals negative 11x plus 4. That's no, it's the exact same problem, and I believe it's going to keep going on and on, or you are going to get an answer to it, something that equals to each other. But where you do it this way, you take off the plus 4 and you add in a negative 11x at the end, then it's a no solution. Okay. So let's go to our last video, which is creating an equation with infinitely many solutions. So pay close attention to this.
Whereas to use the drop down to form a linear equation with infinitely many solutions. So an equation with infinitely many solutions essentially has the same thing on both sides, no matter what x you pick. So first, my brain just wants to simplify this left-hand side a little bit. And then think about how I can engineer the right-hand side. So it's going to be the same as the left, no matter what x I pick. So right over here, if I distribute the 4 over x minus 2, I get 4x minus 8. And then I'm adding x to that. And that's, of course, going to be equal to 5x plus blank. And I get to pick what my blank is. And so 4x plus x is 5x. And, of course, we still have our minus 8. And that's going to be equal to 5x plus blank. So what could we make that blank? So this is true for any x we pick. Well, over here, we have 5 times an x minus 8. Well, if we make this a minus 8, or if we subtract 8 here, or if we make
Hold on, you guys. Okay, I'm back now. Okay, so let's continue with this here.
Make this a -8, this is going to be true for any x. So if we make this a -8, this is going to be true for any x you pick. Give me any x, you multiply it by 5 and subtract 8. That's of course going to be that same x multiplied by 5 and
Exactly.
subtracting 8. And if you were to try to somehow solve this equation, subtract 5x from both sides, you would get -8 is equal to -8, which is absolutely true for absolutely any x that you pick. So let's go, let me actually fill this in on the exercise. So I want to make it's going to be 5x plus -8.
And voila, ladies and gentlemen. Now, if I go back, okay, so he did, of course, the distributive property. Okay, so what he did here, of course, the distributive property, because that is what we need to do. So you got to distribute 4 into x and 4 into -2, which gets me, well, 4 times x is 4x. Then 4 times -2 gets me -8. So you're going to bring that down, 4x minus 8 plus x, bring down the rest of the equation. Now, some of you guys are probably wondering, well, where in the world is he getting the 5x from? Well, you see, we got like terms. We got 4x and then we got x. So he combined those together, which gets me 5. So you got 5x minus 8 equals 5x plus -8. And then there you go from there. So this is an infinitely many solutions. Now, I'm going to let you guys copy this down. We'll take a screenshot of this. And I'm going to stop. And this is it with this lesson here. So I'm going to stop the share in 5, 4, 3, 2, now. Okay, so I hope you guys took notes and pay attention to everything that I cover with this. We reviewed the multi-step equations, the equations on both sides. We did numbers of solutions to equations, creating an equation, a solution to with no solutions, and then we also create an equation with infinitely many solutions. So that was today's lesson. I hope you guys enjoyed that. Now on next, wait, okay, let me pull up my schedule up here. Okay, so let me put my glasses because I can't see. Okay, so the next lesson that I will be covering, which will be graphing proportional relationships. So we're going to do that. I got some examples of that. And also we're going to be doing graphing proportional relationships from a table and also an equation as well. And then also we're going to be covering solutions to linear equations, the intro to coordinate plane, and then also solutions to 2 variable equations as well. So that's going to be on the next lesson that I'll be covering. So stay tuned for that. And I hope you guys 6th graders, you also was watching my lesson as well. as well. So yes, and I hope you guys was paying attention to whatever Andrew was teaching you guys, because I have no idea what he's doing now. But this is how it's going to be from now on. Andrew's going to start it off first, then I'm going to end it off. We're doing it separate now, so our lessons are going to be quite a little longer than if we was together, because when we was together we only had about 30 minutes and I didn't feel that was quite right. So we're now just doing it separate now. So thank you for tuning in, and I will see you guys back on the next lesson. Well, actually next week, next Monday, for the new lesson that I have. So until then, you guys, take care of yourself and be blessed. Wear your mask, social distance, and wash your hands. And I'll see you guys back next time. So stay safe. Have a great your rest of your Friday and your rest of your day. And I'll see you guys back next week.